Evening. How's everybody doing tonight? Good, fantastic. We've got our Ledge crew sitting up there with their beverages. Fantastic. My name is Sarah Grummett, and I just want to thank everybody for coming and joining us here tonight for Cafe Sci. Cafe Sci is presented by PPG. It's also supported by wonderful audience members like yourself. Thank you to everyone who has donated to support this program. If you're unable to donate, but would still like to support the Cafe Sci program, the most awesome thing that you can do is to invite your friends to join us here in the audience or watch at home. Cafe Sci always takes place on the first Monday of every month, and you can register for next month's speaker at carnegiesciencecenter.org. So before I introduce tonight's speakers, I'll just remind everyone that there will be a Q&A after the talk. For our on-site audience, as always, please raise your hand and we will bring a microphone to you. It's important that the questions are spoken into the mic. Online audiences, you can submit your questions by using the Q&A button in the bottom of your Zoom window. You can enter your questions at any time during the presentation, but we are going to hold till the end to ask them. And it's my pleasure to introduce tonight's two speakers, Dr. Anandi Mahadevan and Prashanthi Kukkapalli. Anandi is a PhD biomedical engineer and an MBA who's worked in multiple medical device companies and has led many innovations to market projects. Anandi currently leads the innovation and data science team at Baxter Healthcare as part of digital innovation and platforms team. Prior to Baxter Healthcare, Anandi led multiple development and innovation functions at Omnicell and Philips. Anandi brings over 18 years of experience in digital and data-driven medical devices, including device telemetry, cloud technology, wearables, and predictive analytics in the home and pharmacy. Prashanthi is a data scientist at Baxter Healthcare, driving AI innovation in healthcare and medical devices by implementing cutting-edge data science solutions. With nearly 4 years of experience in the healthcare industry and a recent completion of her master's in data science from Carnegie Mellon, she's passionate about leveraging her skills to the fullest. Prashanthi envisions a transformative journey for the healthcare industry, where data science and AI play pivotal roles in shaping a healthier and more sustainable future for all. Please give a warm welcome to Anandi and Prashanthi.
Thank you, everyone, and a very good evening to all of you. We're really excited to be here today. Thank you, Sarah, for giving us this opportunity and Carnegie Science Center to be here and talk to all of you about AI and its applicability to healthcare.
Good evening, everyone. I'm Prashanthi, and first of all, we're very honored to be here to talk to you about AI in healthcare. Thank you all again for coming, and we really hope to have an interactive discussion with you today. But before we jump right into the presentation, I'm going to go over the agenda that we have today, starting with introduction to AI and Gen AI, different implementations of AI in healthcare, and at the end, we're going to end this presentation on how we can use AI responsibly. So I'm going to now give it over to Anandi.
So if we were to look at the introduction of AI is the new buzzword we hear all around us today. And in fact, we actually utilize its capabilities in many parts of our day-to-day activities. So, but if we were to look at the origin of AI, it really dates back to the 1950s. Doesn't feel so new, does it? The computer scientist Alan Turing started to train a computer to try to interact like a human. And the term AI was coined around 1955 or 56. And in the last 60 years, AI has evolved rapidly. In the 1980s, we saw a lot of applications using the technique of machine learning, which is extremely good at certain specific tasks like classification and sorting. So if we were to think of internet booming in the 1990s and the emails, machine learning is very good at classifying between good email and spam. And in the early 2000s to 2010, we almost call it like an AI renaissance. Why? With the advancements in processing capabilities of computers and having new chips to be able to process much higher data, and with computational advances, with the ability to think like human neuronal thinking, neural networks and deep learning really have become the mainstay of artificial intelligence. These are very popular and have widespread applications like facial recognition and auto learning. And with even more advancements in technology, we have seen natural language processing flourishing. And in 2017, with the transformer architecture, we have seen large language models really take on a lot of applications. We're going to go into a little bit of details in each of these spaces, but if we were to look at everyday examples of how we use AI, right from FaceTime ID that each of you use on your phone to unlock your phones, to Google Maps, to Alexa and Siri, without whom we cannot live today, and our homes that are not just homes, but have become smart homes. We are here to really witness the growth of technology, right? From self-driving cars to a lot of newer applications. And if we were to look a little bit deeper into the technology aspects of this, the term AI is really an umbrella term. And within this umbrella term, there are a lot of different methods that can be used for many different applications. And why this image is important, to be able to figure out which methods to use, which algorithms to apply for which specific use cases, and how do we enable the best possible outcomes. It's really important to understand the techniques and the subsets of these algorithms that form the broad umbrella term artificial intelligence. So if we were to look at artificial intelligence, it's really any technique that enables machine to perform or mimic human intelligence. We talked a little bit about natural language processing, where nowadays we have computers that are able to do a lot of that. Computer vision, which enables robots to look deeply into certain aspects of images. The next set that we will look at is really machine learning, right? And this is a very big umbrella term, again, within the large subset of AI, where we have algorithms like clustering and k-means and logistical regression. And what does machine learning do? It really uses statistical signal processing methods and enables machines to learn to improve at specific tasks. It follows a specific workflow. Advantages being machine learning can work on small sets of data. So it's almost like you can start to get some predictions in real time. It does not require extensive computational process. So it can work on a small computer without having to need any large costly processing capabilities. It takes less time to train, but on the flip side, it has limited tuning capabilities and can be inaccurate in certain complex tasks. And then within this, if we look at deep learning, I did mention about neural networks and deep learning starting to become the mainstay of AI. This is a subset of ML algorithms that makes use of the neuron architecture similar to human neuronal thinking. Just like we see things and are able to process information, deep learning really takes in a lot of data, self-learns features, and is able to predict outcomes. So what are some of the key features? It requires large sets of data. Because it requires large sets of data, it does require a higher computational processing capabilities. But advantages being, it can be tuned in n number of ways and can provide really accurate outputs. I further want to enhance how these processes are different or similar in certain ways. Let's take an image of the cat. Like I mentioned, machine learning follows a specific process. So we will input a set of features, which we will say like it has sharp ears and it has whiskers and it has paws, and we'll try to define n number of features that will be used to train the model, and it will predict an output. And it will at the end of the day say whether it's a dog or a cat. But if we were to use deep learning, we're just going to feed it many different images of cats and dogs, and it will automatically start to identify the differences in features based on the neuronal architecture and the number of network layers it has in between, and be able to correctly identify the image. And as we get into deep learning and the new transformations in AI, which is generative AI, Prashanthi is going to walk us through the details of the technical aspects of generative AI.
Thank you, Anandi. So now that we learned about what AI is and different domains that we have in AI, let's now talk about generative AI. So what is generative AI? We can view Gen AI as like a magic genie in a box, but instead of it granting us wishes, it would help us generate stuff like data, images, audio, video, etc. In addition to that, it can also help us predict outcomes and can also simulate complex events that we have in real life. So we have three main stages that any Gen AI model would go through. The first one being forming a database. So for any data science or AI model, it's very important to gather and curate data, especially for large language model when the data can come from Wikipedia pages, different Google sources, and also images that we have available online. All of this data forms a basis for this Gen AI model. For example, the recent hot topic ChatGPT has around 42 terabytes of data which it has been trained on. So you can imagine the amount of data, and that's the reason why it's one of the largest language models that we have today. So once we have the data ready, the next step that we have here is inputting a prompt. So prompt can be a description of whatever you want your model to output. Like it can be as simple as a plain text with a single sentence and can be as complex that you are adding context to that prompt. I'm going to pop in a small example here. Let's say you want to dedicate a poem to your friend. Most of us are not poets, right? At least I'm not. So I would like a help of an AI model. So if I just say that, can you please provide me a poem that I can dedicate to my friend? Chances are highly likely that it can pick something off of the internet and give it to me. So my friend wouldn't like that. So instead, if I'm going to go and put information in prompt, if I can add some of the memories that we had together or maybe their qualities, then we would have more personalized and curated poem for my friend, which they would enjoy. So that is the magic a simple prompt can create, and the way we structure it will depend on how model is going to produce output. So last and final step that we have here is generation of output. So imagine we got 5 different outputs from a model. The most appropriate one should be chosen, and we need to implement multiple ML algorithms and ranking models according to the use case that we would like. So these three, in a nutshell, can be considered as different stages that we would have to go through in order to implement or deploy a Gen AI model. So now that we have talked about it, these 6 are the most commonly used or the top Gen AI models that we have in market today. We have more of them, but these are the most common ones. So the first one, starting with, we have generative adversarial networks, which is widely used in image generation or art creation these days. So I'm going to go into the details of it in the next slide, but we also have other models like autoregressive models and transformer-based models. So we can consider this as horsepower of what is behind ChatGPT today. And the last and final one, we also have reinforcement learning models. These are very popular and can become revolutionizing force of AI in the next generation because they can more or less act like a human. So on how, if you provide feedback to a human, they can implement that in their next output. That's exactly what reinforcement learning models does. So we don't have to go and train the model back and fine tune it. Instead, we can just provide it feedback and it can act like a human agent and respond to us. So that is why it is very famous. And now let's talk about generative adversarial network architecture. But before me going too technical into it, let me start by giving a small example here. Let's say we have thief and a police. So the task here of thief is to generate counterfeit notes or fake currency. And the job of police is to find what currency is fake and what is real. So our thief failed to do or failed to produce fake currency because he's not a pro in that. So police is so smart and he found out that the thief is cheating, and the thief was unable to fool the police. But after a few attempts like this, thief became very powerful and successful in generating fake notes, and he was able to fool and deceive police in the final end. So this sort of a game between police and thief is exactly what happens in a generative adversarial network architecture. So the thief here is the generator model and the police here is the discriminator model. So generator model takes random noise vectors and tries to create images, audio, or data as close as to the real examples as possible. And the task of discriminated model here is to classify what is real and what is fake, or what is coming off of the internet, or what is coming off of the generated model. So this whole sort of back and forth, or like a little competition between generated model and discriminated model, is called zero-sum game in game theory. And in ML terminology, it's called adversarial training, because it's trained on large data set until the generator can realistically understand what is real and what is fake. And because our generator got amazing accuracy and was able to provide or fake data as good as possible, that's the reason why this is widely implemented in image generation, art creation, and video generation today. So now that we talked about AI, domains of AI, generative AI, and different architectures, now Anandi is going to go over implementation of AI in healthcare.
Thanks, Prashanthi. And now that we understand a little bit of AI, and AI is a very broad term, right? There are applications that exist today in healthcare. So if we think of surgical robots, and the picture up there actually demonstrates one of them that is used in complex surgeries. In its simplest terms, it has plenty of arms equipped with cameras and mechanical arms that can be controlled with precision by the surgeon to be able to, first of all, with the camera, give them a view, a magnified view of the surgical site, and then be able to really provide tiny incisions to be able to do the procedure, making it a minimally invasive procedure, leading to better outcomes. So surgical robots are extremely useful in these kind of complex procedures. I'm not sure if anybody in this room has tried out a HoloLens or an augmented reality glasses, but if you have, it's a lot of fun. In terms of AI, augmented reality allows you to view images like an X-ray or an MRI and overlay it on the patient anatomy for the clinician to be able to prepare and have a better care plan action for their particular patient. If you've seen robots going around Amazon workshops, we do have robots that actually go within hospitals. And there are robots that automatically fill medications for a specific patient order. They're packaged, and then they're carried by these robots and delivered to patient rooms, minimizing the workflow of caregivers as well as pharmacists. And Prashanthi covered in detail Gen AI, but we are just at the cusp of it. Generative AI is really transformed healthcare in a manner where today there is a lot of need for improvement in documentation. And generative AI can really play a big role in this aspect, as well as she talked about how it can be personalized. So in terms of drug discovery and personalization of medications for any particular patient, generative AI is going to be the future of some of those aspects. If we were to look at a little bit deeper into healthcare, these are all areas which need some help or the other today. We're going to talk about two specific use cases, which is caregiver workload and early diagnosis. Before we go into the details of those two use cases, I do want to touch on the other three mentioned here. Remote patient monitoring. How many of us use a wearable today? Anybody? Okay, we have a couple hands. Or most of you use a smartphone, which also tracks. In its simplest form, what does it do? It tracks the number of steps you've taken. It tells you how many calories you've burned. It maybe gives you insights into the quality of sleep. It tells you how much deep sleep you had. And it really starts, if you're sitting for too long, you have sensors that tell you you've been sitting for too long, you need to get up and walk. That is helpful, right? It's providing you a feedback to take action. There have been published research out there that shows that the quality of sleep, the length of sleep at night, and the disturbances in sleep can really start to predict early trends in onset of feeling unwell or a disease. Now imagine a loved one who has, say, COPD or a heart disease. And what if we were able to put a wearable or a patch on them that measures their heart rate, their SpO2, their activity levels, and their sleep? And using a combination of these parameters, along with maybe a few others that I may have missed here, if we are able to identify worsening conditions or patterns, changing patterns in the patient's health condition, triggering an onset of early exacerbation, it would greatly help in patient outcomes as well as significantly reduce the cost of healthcare. Remote patient monitoring not only applies to chronic conditions, but think of a patient who has just been discharged after any specific procedure and needs to be monitored for the next 30 to 60 to 90 days. How can we have a care plan that enables us to make sure that the patient is recovering as expected versus, having a boomerang and coming back into the hospital? The goal always being, how can we intervene early and proactively? And remote monitoring will actually continue to keep growing in this particular space of healthcare. Virtual health assistants. If we have to have a procedure or a surgery, our mind has plenty of questions. We have to go to the website, we think of calling a nurse, asking many questions, and for a further aged person, it becomes even more complex. Number of comorbidities, what kind of medications I can take before a procedure, what I cannot do, before a procedure. What if we have health assistants that are able to provide these patients with correct, meaningful information in a timely manner, that their mind is put at ease before the procedure, during the procedure, and after? How can we take care of all of that, both for the patient and their family members, so that, again, the quality of care that we provide to our patients is exceptional and their road to recovery is critical? Resource optimization. Cost is a big factor in every single industry, and healthcare is no exception. How can we have AI-driven algorithms that tell us how are we utilizing our resources? How can we manage the fleet of equipment, the fleet of devices, better and in an optimal manner? How can we predict for patient admission rates? How can we have discharge, bottlenecks in the workflow of how a patient moves through different care areas be managed better so that we can plan for better staffing and better cost optimizations across the entire workflow of healthcare? These are all areas where generative AI can actually help. And with that, let's dive a little bit deeper into the two use cases that we said. Caregiver workload. The statistics that you see on the screen are coming from American Association of College of Nursing. Of course, fueled by the pandemic. In March of 2022, when the survey was done, 52% of nurses consider leaving their profession. 60% of the acute care nurses feel burnt out. And 75% of the nurses expressed feeling frustrated and exhausted. These numbers are staggering. Nurses are one of the core caregivers in a hospital setting and for patient care. Insufficient staffing rates, rise in patient readmissions, has really negatively impacted the health and well-being of these nurses. And they feel unable to deliver the type of care that they actually want to deliver for their patients. The impact being rampant nurse burnout. And while that is for the nurse frustrating, on the flip side, for the patient, it means higher recurrences of infection causing readmissions. And the study also says that higher patient turnover with the nurses causes an increase in mortality, and we see a 6% higher mortality risk. This is scary. What can we do with technology to help our caregivers remove some of the burden and help them with some of the administrative tasks that they need to do today? One is we eliminate the manual work that they need to do and automate workflows. And two, how can we provide them not just more data, but actionable insights and recommendations into how they can better, provide patient care. So how do we do this? We're going to walk through an example of how we potentially do this. So think of a patient who just came into the hospital. What's the first thing we do? The nurse takes some vitals, heart rate, blood pressure, temperature, SpO2. What do they have to do? The first thing they all need to do is take these readings and go enter it into the EMR. I mean, the patient will be sitting there for some time because things need to be entered into the EMR. How can we automate the workflow to ensure that those readings can automatically go to the patient's chart and that the nurse does not have to remember to do this in a manual manner afterwards? Once the patient is in the hospital, they need to be administered with many different types of medications. How can we have tools that augment or complement the tools in the EMR to ensure and improve medication-based alerts to avoid any type of medication errors and even fatal drug interactions for any given patient? And for each of these use cases that I talk about in this whole chart, you're going to see that you need millions of data points, but based on all of those, you're able to train algorithms to figure out prescribing patterns, what are some of the limits, and how can we provide auto alerts in case any of those get exceeded. Labs. When they go into a hospital, again, there are labs that need to be taken. How can we identify if based on their diagnosis codes or the previous lab that they either need another lab or not, both increasing efficiency, reducing the caregiver burden, and optimizing cost. Then the nurse goes through the day, depending on the care area they are in. Sometimes they have 6, 7, 10 patients. At the end of the 8-hour shift, they need to hand off to another incoming nurse. And they need to provide a detailed account of everything that happened during the day for all these patients so that the other nurse is able to pick up and provide the same level of care to our patients and our loved ones. How can we have a standardized template that ensures that certain details are never forgotten in terms of patient-nurse notes, and that she's able to review, edit, and sign off to be able to share those in more detail with the incoming nurse? Clinical decision support. Data across healthcare is actually scattered in many different systems. It's not just the EMR where all the data sits. How can we have a central point where all this data is collected, whether it's from EMR, whether it's from the vendor devices that are displaying heart rate every second, ECG or SpO2, and bring this view to the clinician and the nurse in context of the patient, a patient holistic centric view, which will allow them to look at the data for the last hour, last 8 hours, last 24 hours, see the trends in how they have performed over a period of time, and maybe make adjustment plans to any of their medications if needed. That is clinical decision support, because certain things require many data points to come together to be able to make the next decision in terms of their care plan. I think I've already talked about drafting responses to patients' queries. And then if we think through this journey again, on patient discharge, there's a lot of summary that needs to go home with the patient. How can we automate that so that the patient understands which medications, at what time, do they have a follow-up visit? Has that already been scheduled? And how can a lot of that data be automated for a nurse to review and sign off, or a physician to review and sign off? Each of these tasks have a lot of documentation aspects to it today, where generative AI can truly help. And Prashanthi talked about reinforcement learning. The algorithms today, based on the data that you feed and refeed in, will actually learn and be able to produce more accurate outcomes. And to be able to do this, both Lancet and NIH have published studies that say we need multiple pilot trials that will help us to be able to do these tasks accurately and gain confidence from our clinician friends to be able to use these tools in a much more optimized manner. Prashanthi is going to walk us through another use case that is used in clinical support.
Thank you, Anandi. So Now that we learned about how to implement AI in reducing caregiver burden and improving operational efficiency, let's also look at how we can incorporate AI in clinical decision support today. So I'm going to now talk about diabetic retinopathy detection using AI. But before going into technical details, most of us know that diabetes is one of the most common diseases that we have today in the world. As stats also say, around 40 million people in the US have diabetes. Diabetic retinopathy is a condition because of large amounts of sugar in the blood. Small cotton wool-like spots or microaneurysms form in the blood vessels of retina. It can actually lead to vision loss or blindness. 95% of DR can be saved if it is diagnosed at an early stage. So 95% in 9.6 million is a lot. So most of us might be questioning that if we have ophthalmologists today, why do we need AI? First and the foremost reason is it can lower workload on ophthalmologists. What if we have like a simple AI tool or an app which we can basically sit at home and use instead of us going every now and then to a doctor or have like a doctor appointments? It's going to even reduce workload on ophthalmologists in such a way that, I mean, we completely reduce the doctor intervention. And if we can, we'll be able to diagnose that sitting at home, that says a lot. And the second important reason that we have here is most minor lesions can sometimes be missed because of human errors. And there is a chance that AI will be able to recognize that. Let's talk about the architecture of how diabetic retinopathy detection can be solved using AI. As we talked about earlier, for any data science or an AI project, it's very important to curate data set, especially in clinical diagnoses when we need data from different sizes, different ages, gender, different geographical locations. It's important to keep our data set as unbiased as possible and as diverse as possible. So this is the first step that any model would go through. And the second step that we have here is the data pre-processing. Because the data came from multiple distinct sources, there is a chance that it's not going to be consistent. So it's important for us to take the data and resize it, apply median filters, and apply sharpening techniques so that the data that we have and all the retinal images that we have are consistent with each other. Once we have the data ready, the next step that we have to follow in any AI model is extracting features. Without losing significant features, it's important for us to understand a pixel and the surrounding pixels and density of them. Once we have that, we also need to reduce the dimensionality because we would want to get rid of features that are not useful. Once we have final processed vectors ready, the next step that we should follow is ML classification algorithms. So here, as we can see, diabetic retinopathy has 5 different stages, starting from normal to severe and proliferative. So it's important for us to take these vectors and classify them so that we'll be able to see what that retina image belongs to, which category does that belong to. And when we apply ML classification algorithms, we will not get the data or probabilities that we get are not normalized. And we need to apply softmax function so that if we add all the probabilities that we get for these levels, they add up to 1. So in a nutshell, this is how ML classification algorithm for diabetic retinopathy detection using AI. So now that we talked about AI, domains of AI, Gen AI and its applications, let's also learn about how to use AI responsibly today.
If we were to utilize these new AI techniques, what is it that we need from a development perspective? Is it technically feasible? I think we've mentioned multiple times in this talk that Gen AI models require large sets of data. Do we have the right data sets with the right data quality, or do we need to plan for some strategic partnerships, whether it's with payers, vendors, hospitals, whomever, to be able to acquire those data sets to build these accurate models? 2, is it cost effective to be able to build this model? When we talk about internal readiness, do we have the right talent? Because these are new technologies that are coming up every day, or do we need to train our talent? Do we need to acquire new tools, or do we have tools that we can get from third-party vendors or even open source technology? Do we need a specific in-house capabilities, or can we work with some other folks to be able to build these? And as a part of both internal readiness and external readiness, each of these applications will make sure, we will need to ensure that we have the right IT infrastructure in place and the right firewalls to be able to entertain such solutions. The other side of the coin is really the value that these kind of solutions bring. And we need to be explicit. Is the value in terms of increasing revenue, or is it actually increasing operational efficiency in our care settings, leading to cost savings? Is it helping manage risk better for our patients in the hospital, or is it improving caregiver satisfaction, patient satisfaction, and overall scores for the hospital? Identifying the value upfront and being able to demonstrate feasibility of that value is critical for better adoption of these tools. And within the healthcare realm, it's not if we adopt, it is more of how we will adopt and make it happen in the healthcare space. And with every technology, using it responsibly is our duty. So let's take a look at some of these topics here. No caregiver, no nurse, or even you or me just don't want more data being thrown at us. We want insights to be delivered from that data. What does that mean? How did you come to that diagnosis? Or what was the recommendation? Tell us the why of why you came to this decision. And that combined with striking the right balance between automation and oversight. And when I say that, how can we provide details of transparency of how the AI algorithm comes to its conclusion or recommendation? If it's a black box and they don't understand it, they're going to be hesitant to use it. How can we provide them the details in a transparent manner that they can use it to their advantage to make the best decision for the patient when such a recommendation occurs? And that's that striking balance. And this is very critical in the healthcare space because every patient counts. Because we are dealing with sensitive data, cybersecurity is of paramount. Having the right technologies in place to store data securely, both at rest and in transit, and being able to show certifications like SOC 2 and high trust, and working with the IT departments of the vendors is very important to be able to utilize these particular solutions. Along with that, there is always going to be a threat of a malicious actor. What happens in the event of a breach? What steps and protocols have we laid out to be able to recover from that breach? And then having options to opt in and opt out of being able to use AI and not, because nobody should feel forced to use any particular technology, are all important aspects and a big part of the cybersecurity piece. Healthcare regulations in different countries are different. So compliance with regulations like HIPAA in the US, GDPR in the European Union are very important. Because in European Union, you are not allowed to have data cross boundaries of Europe. So you need to also have IT infrastructure in place to be able to host data in data centers that reside in these specific countries as a part of their regulations. Prashanthi spoke about how AI creates content that can be both real and fake, authentic and fake, right? How do we have mechanisms in place to be able to detect the authentic content versus the fake content? Because if you have an AI algorithm that is producing content that very closely resembles the truth but is false, and think of an actual patient image having that, that could pose some serious challenges in the healthcare setting. And because, again, generative AI produces content that very closely mimics human-created content, there is a real fear of infringement of intellectual property. But with all these things said, if you use AI irresponsibly, you're going to have severe penalties and a loss of damage to reputation. Using AI responsibly is a collective effort. This technology is here to stay. We're going to see a surge in the number of applications that are going to be built based on the use of this technology. And we're going to witness a shift, a paradigm shift in the healthcare realm using these technologies. So it's not if or when, it's going to be how, and how well prepared we all are. And the more trusted AI partnerships we can build across vendors, payers, hospital staff, and patients, the better we all are going to be in being able to adopt these technologies for the betterment of all our futures. With that, we'll open it up for questions.
All right, thank you very much. As a reminder, we have Sammy that will be coming around with a microphone. Please do use the microphone to ask your questions. And for those of you watching online, don't forget down in the bottom of your Zoom window, you can find the Q&A box. So please type your questions in there and we will ask those on your behalf.
Okay. First, let me say thank you. That was incredibly informative and at my level of understanding. I'm not I'm a college-educated, non-science major. Dr. Anandi, I think probably you have heard some of the limitations of data sets that don't represent all of us, especially in things like facial recognition. There are some limitations as to race or gender. There have been some scientists who have talked about being African-American, having Black skin, and the problem with with inaccuracy in the data that's been offered or put in. And I'm wondering, when you are looking at something like diabetes or looking at some medical conditions, what provisions do you think or should be there to ensure that all of us are represented in that? Thank you.
That's a great question. And, again, as technologies are evolving, so is the accuracy in being able to look at a lot of the content is evolving. So it's not a done deal, and I'm sure we're not there yet. But we have the technology in place to be able to do it. The question is, again, when I said, how do we use it responsibly, especially in the healthcare space, how do we have it such that it's a recommendation that can be validated by a clinician or a caregiver before an AI model automatically makes some changes on a prescription or on any device for the particular patient? So we want the clinician to be able to take the final decision for a patient, but how can we augment them with some of these data insights that are coming from tools like this will be the key. And as these, as we feed more and more data into these algorithms, they're going to get better and more accurate. So we absolutely need pilot data, pilot trials on a lot of data and maybe on a lot of different aspects of patients, not just one subset of patients, because it's not going to be enough to be able to train the algorithm to pick up every single thing. So we might need to do trials in multiple areas, multiple countries, different population types, meeting all the 5th to the 95th percentile coverage to be able to ensure that the AI algorithms are able to identify features that are specific to certain populations as well. So those are all areas that will evolve. And hopefully, the clinical decision support can be more of an augmentative arm until that point before it starts making decisions by itself. Prashanthi, anything you would like?
Yeah, I think that perfectly makes sense.
Got one down front.
Yeah, thanks very much. So in 1957, Paul Meehl wrote this great article called "Why Do We Use Our Heads Instead of a Formula?", where he was saying that we have all these great predictive algorithms in 1957 for healthcare and medicine, and nobody used them. because doctors really are very interesting people. They trust themselves more than anything else. In 1990, a fellow named Kleinmutz wrote an article called "Why Do We Still Use Our Heads Instead of a Formula?" showing that nobody had listened to the 1957 article, and that we have better predictive algorithms now, and we have more data, and still doctors like to listen to themselves because they feel they have unique insight into their patients. Turns out that every therapist thinks that they're better than average. This can't possibly be true, but that the algorithms don't apply to them. I'm wondering, as the machines are clearly getting better, what we're going to be doing on the human side to aid adoption and to deal with specifically physician reticence to trust anything but their own heads.
That's again a very great question, and I'm glad you brought it up, because and why I brought up that last slide of being able to adopt it and considerations for use case is very important. It's not been easy to adopt technology in the healthcare domain. Indeed, healthcare domain is one of the biggest lags in terms of adoption of any new technology as compared to the any other sector. But there are reasons for it, right? We're dealing with patient health. Every life is important. We cannot have the machine make any mistake, because then who takes the responsibility for it? Becomes a big challenge. So again, working in trusted partnerships with caregivers, vendors, payers, and payers are very important aspect of this equation in the US healthcare system, right? Because they control what gets paid for, what procedure gets paid for, what technology gets paid for. It's not the patient at the end of the day deciding it. So they are a key aspect, and how do you bring them along this journey? I think there has been a shift in the thinking, where there is more openness and understanding. And that's why I also said, I think we need to be transparent about how these algorithms are coming to a decision. If it's just a black box and we say magically, hey, I made a recommendation, I think there's going to be a hesitation. And I, as an engineer and scientist, would think twice before saying, I'm ready to use it. How can we be transparent about how these algorithms are making these decisions, make that trusted connection, and have them embrace this technology as an augmentative tool, not to replace them, but to really help them in making decisions and making their lives better.
Thank you. Our next question comes from Jennifer on Zoom. What partnerships already exist in data collection in healthcare, and how can those partnerships be widened via vendors, payouts, etc.?
I may not know about all partnerships that exist in healthcare with respect to vendors and payers. Obviously, the EMR systems host a lot of the data today, and they do try to partner with a lot of other vendors to be able to still input that data. You also have things like different specific data collection centers that actually are both payers, providers kind of a thing, where they have access to more data. They have de-identified data in many instances, and they are able to share that to be able to build these algorithms. There is more of a progress on that end, but I may still not be able to answer Jennifer's questions of what are all the partnerships that exist there. It's, I think, a trend that is definitely making progress, and even we as vendors are continuously seeking to have those partnerships to be able to better provide insights into data, because we do realize that just one set of data is not enough to be able to really train these algorithms and come to the right conclusion. So we're always on the quest for newer data, and if she has any insights, I'm happy to take some.
I also want to thank you for coming this evening. And I'm a social worker, so I have questions about consent. The AI consent model seems problematic to me. An example, I have a friend who has a monitored CPAP who has decided she would rather die and will not use her CPAP. But she will not get a non-monitored CPAP because that's how it is. So this is a way in which, technology has offered this opportunity, but she feels like the systems weren't built for her, they were built against her, and she doesn't want it to be monitored. Nevertheless, she's just out of luck at that point. I think, in our model of how AI works in the hospital, where informed consent and AI seems like a real problem when you can't, informing people to consent seems like a challenge. How do we teach people enough about AI to make them be able to consent And how do we continue to give them options if they don't want to consent to participate in AI medicine?
And that's why I mentioned about opt-in and opt-out procedures, right? I mean, you need to have the ability to opt out of a program if you do not want to participate in it. It cannot be a compulsory aspect of a patient's care plan. And that is very important to gain their trust in these kind of tools and feel like they are being heard and monitored. And two, can we add different aspects of, changing the rule set within that AI model to be able to ask them and provide them more different options. And maybe Prashanthi can give us an example of how Gen AI can potentially do something like that, where it can create content for consent. on the
Especially
patient.
implementation of AI in healthcare, I think, is a very sensitive topic, and especially you can provide options. So, for example, I can take diabetic retinopathy. You don't want to misclassify someone having diabetic retinopathy as not having diabetic retinopathy, but it can go vice versa. So, there is always a sensitive balance between precision and recall that we need to consider, and especially with parents. Patients' consent, it's also important to understand if they're ready to take that step.
Did we answer your question? As best as we can.
Answering
Yes.
my question. Yeah.
Hi. My question is about getting some heuristics for if I have like an idea for AI, how do I know if it's an idea that the technology is ready for today, or maybe it's something that I should wait a few years for? I understand that we need a lot of data, and that's one thing, but maybe, there's other things, like maybe it's not good at, I don't know, coming up with long processes or something like that. Are there categories of problems that AI is not good at that we should know about?
I would say more than not good at, it's really about identifying the right method that is applicable to the right use case. And that's why I went through that model that talked about machine learning, which follows a specific process, but requires very little data for training, right? It also depends on what outcomes you're looking for, while deep learning or the neural networks would require a much larger data set. So it really depends on use case and us being able to tease out some of the steps of, okay, what is it that we need to do? How much data do we need? Do we have the right inputs? Will all dictate which kind of algorithms we would use. Again, AI is a very broad umbrella term. It has plenty of algorithms within it. There are some that are going to require a lot of data and are going to work great. There are some that are going to require less data, but are going to be exceptionally good at specific tasks. Now, they may not be good at everything. Like a Gen AI can create content. Now, a data set that's working, a model that's working on a small data set is not going to be able to do that. But it can definitely do the task that it was asked to do in an accurate manner. Right. So I think there are various aspects of it that we need to consider. And like I mentioned, the considerations for use case, right? It's both technological feasibility as well as value. What is the value you're bringing, and how can we, bring that to the fore in a proper manner? Anything you would like to add?
I have two questions. One is technical and one is policy. So let's try with the technical one first. A major theme, as I understand it today in healthcare, is personalized medicine. Is that accurate?
Did you say that
Personalized medicine
is a major theme today?
Is that accurate?
It is, and it's an upcoming theme, I would say. Yes.
Okay, so we'll take the premise, it is a major theme.
Yes.
The other side of that, if we go over to your discussion of classification, fundamentally classification is about finding clumps of similar situations, which is antithetical in my understanding to personalized medicine. So we have this dilemma, it seems to me. If one theme is deal with my particular genetic composition, and your structure is to find commonalities among multiple thousands or hundreds of thousands of people, these two things seem to be moving in opposite directions. Do I have that correct or not?
Sorry, I didn't get the question.
Fundamentally, classification analysis is about finding centroids of similar kinds of objects, whether that's people or physical entities.
Right.
That is different from individualized focus. By definition, individualized focus is focused on me, not on the clump that I am part of. And I'm asking, do these two paths, which seem to me to be orthogonal, are they, or are they somehow compatible?
So they are compatible in a manner that the classification, I mean, obviously, first you start with pattern recognition and pattern generation, which is what classification is based on. But as we start to look at these patterns, and where we said about personalized medicine was drug discovery and its applicability to certain specific conditions, right? It's more of figuring simulation models where you have those patterns, and now you're using the drug to simulate if for this genetic model, this particular drug is being able to work well or not. So it takes both those orthogonal dimensions together and is now able to learn from it and be able to produce an outcome. So it is orthogonal in one dimension, but when you bring it together, it forms a circle which helps us actually identify what are areas where those similarities would work and what are areas where the similarities will not work, and why do we need to personalize it in that particular instance. Something you want to
When we speak about classification, I think it's also important to not be biased towards one specific gender or one specific geographic location, because in long term, if we provide like maybe 90 examples of one location and the 10 remaining are from different, it is highly likely that the output is going to be from that 90%. So because of that, it's important for us to understand the
I hear you. I just don't see that as anything other at this point than talk. Okay, because fundamentally, if we look at classification kinds of frameworks, just this clump, that clump, that clump, that clump, and I am in this clump, then from that perspective, I should be treated using this clump as at least a first priority, as opposed to something unique about me in the first priority.
That is correct.
Okay, so I'm asking then, how do these two fit together? You suggested a hierarchy. First, clump it, and then you find what's different about it.
Correct.
Okay, is that basically how your work is proceeding? Or is that just kind of your answer to the question?
I mean, I'm not a drug discovery expert, so, I don't want to say that is exactly how work is proceeding, but I would say, I mean, it could apply because, again, each of these AI algorithms don't work in isolation. Indeed, it's a combination of multiple algorithms that help us reach the output. And that is why I mentioned that, like even in whether it was generative AI or the other AI models that you looked at, it's not just one feature that is identifying us in one direction. So it's a combination of multiple factors where clustering or that, first set of feature generation that we all go through is similar. And then we start to identify differences. And then if we need to target those differences, what aspects do we need to consider to be able to target those differences, which is where potentially personalized medicine plays in. But I'm no expert at that, so I don't want to say with confidence that that's the answer. I was trying to just give a perspective of how it potentially works.
Fair enough. The second is a policy question. Clearly HIPAA has a very different policy objective than the EU GDPR.
Yes.
One deals with privacy in general about all information concerning me. One deals only with healthcare information under certain circumstances. So it would seem, again, the policy dimensions drive significantly what in fact you can produce as products.
Yes.
Is that accurate?
Yes, it does. And that's why I mentioned those regulations are super important because they do make us go in one direction or the other, depending on the countries in which we are building solutions for. Thank you.
All right, we'll take a question from Zoom. Brian is asking about medicine interaction alerting. His question is, how is AI being used to improve medication interaction alerting beyond what existing alerts? Beyond. Hello. My microphone went out. There we go. We're back. How is AI being used to improve medication interaction alerting beyond what already exists? Beyond what EMRs provide using known medication interactions in clinical studies?
I cannot talk for what exists and we want to be careful about what we share and not share. But what I can say is that there are algorithms that are actively being researched and worked on, where they take in input from millions of data points, whether from EMRs and other places, use classification from NHSN standards and ATC drug class and drug load, and then be able to map out like the drug limits and the safety compositions and the prescribing ways to be able to identify deviations, what kind of adverse event did they have. So all of this information really needs to feed into the algorithm to be able to come with an outcome. And there is active research that there are different companies who are doing it and I really want to be able to help in this particular space.
So I have a more technical question. Obviously, as you're gathering these terabytes and petabytes of data for analysis, you're using supercomputers to analyze it. So when this rolls out to hospitals or clinics or doctors' offices, what kind of equipment will they need? Can you build your programs so that they don't need to be connected to a supercomputer?
So once we have built the models can be deployed on computers that can run on basic processing capabilities or in the cloud, right? They can run on the cloud with higher computing powers and servers. But it's to really first get the model trained and be able to get to the outcome that it is recommending to, which will need that supercomputational powers. But once that first part is done, the retraining again would happen there, and then the deployment occurs at local levels as well as in the cloud.
Thanks. One more coming in from our online audience. And this question has multiple parts. With this technology here to stay, do you envision or hope that the development and implementation will be carried out primarily by industry, academic research institutes, or government agencies like NIH or perhaps the Department of Defense?
I would say they all need to come together in some form. I mean, NIH is a key aspect of a lot of our health policy framing and research. Industry leads the trends in many ways in being able to absorb new technologies and being able to apply it. And academic research is critical as a component of this to be able to take those ideas and the research that people have done so much work on for years and be actually able to bring it to a tangential outcome. So it's really, again, an interplay of multiple actors here that need to come together to be able to bring these type of solutions to the market.
Thanks. And the second part of this question is, what do you see as the advantages or disadvantages and possible dangers with whoever ends up being the major player in the development of the AI technology we're talking about tonight?
I think given the fact that, we're just scratching the surface of the AI technology, and it's almost like an arms race, right? Whoever is the first to win gets it. But using that AI responsibly and being able to make sure that it is accurate is extremely important. Otherwise, whoever is in that arms race also loses the most. So it's a little bit of a war game here with AI. But of course, whoever wins the game does win, in its best aspect.
I can think of three questions, so I'll just stick with one for now. I've heard that, large language models can sometimes have hallucinations where they just make up stuff. Like cafes on Mars or something, depending on the prompting. And so it's hard to, they're so complex, it's hard to actually calculate an exact error rate for a given input because you have so many things that are tuned during the training. And, I think, could this be similar to errors that people make? And so say on a very tough case, like criminal trial, you have 12 people making the decision. Well, we ultimately, for really tough cases, need more than one AI model and have them vote or something, simply because it's too hard to come up with an error rate.
You want to be able to repeat it? I think just to make sure that I followed your question, was your question that, will we have like multiple AI models, being able to go for decision making? Or,
Yeah,
I'm sorry, you got
if
cut in
you have a
between.
really tough case, say some cancer that's hard to diagnose or some subtle condition, can you just rely on one AI model if you don't really know what its error rate is? Like, sometimes people get a second opinion from more than one doctor. And on a jury trial, you have 12 people. Now, nobody goes to 12 doctors, but will we need more than one AI model?
That's a great question. And actually, maybe we didn't think of it this way, but you're right. First of all, the AI model does choose from a multitude of models that it already, performed to be able to choose the best as well and rank it the best in terms of both features, weights, etc. that it does. But would it need more than one model in many different ways? Maybe yes, right? Again, as we look to the future, I would say definitely, given that the advancements in technologies are really rapidly increasing on a day-by-day basis, we might want to have multiple models compete against each other to produce the best outcome, but also have it verified by a clinician, right? To your point, should we have one clinician and should we go for a second opinion? Similarly, do we have like multiple AI models spitting out their outputs and the physician may be reviewing the top three, right? Like a jury decision making. Those could be ideas of the future for sure. I don't know if they're being done in today's use cases in any particular instance, in any other industry like that.
I think, yeah, that is the case because it's always good to experiment with multiple models, especially if you want to choose one for your use case. And also on top of it, it's also vital to impose classification algorithms because the models outputs that we get today, especially from large language models, are very diverse. And if you want to choose it appropriate to your use case, it's also important to apply ranking models on top of it, for sure.
I wasn't going to ask another question, but I hear a lot of overlap here. There's a number of questions about AI models, where they come from. Someone asked online about whether it was going to be government, industry, who was going to develop them. This nice lady asked about race and racism and AI models. He's asking about multiple AI models. In the end, what is interesting to me is that all of the current models are created by the same people. The same white men are creating all of those models. If you're in Pittsburgh, it looks like there's women in computer science, but I worked for CMU. That's not true outside of Pittsburgh. If there are not Black people in computer science, and there are a few people of color, period. A lot of those models, and it's true in medicine as well. So we have two overlapping fields where all the ideas and all the visions are from the same very narrowly defined upper middle class white men of our society. It seems urgent to have better AI models, that we get a broader group of people in our society to participate in building them. What will possibly motivate business, industry, education? Is it going to have to be lost? Whatever it's going to take. How can we motivate a more diverse community to build these models that are going to run our world into the next century?
That's a tough question. I'll give you that. But again, the AI models by itself are going to give us outputs based on what it is trained. So if you're going to train it only on a subset of data, that's the output we're going to get. our goal as whether industry folks or whether, social workers, whether anybody here, would be to ensure that for fair training purposes, we're able to identify the different sources of data and the different sets of data to make the model as unbiased as possible in its outcome. That would be a goal that all of us have to collectively take. And hopefully that if data is coming from, hospitals and vendors and payers, we'll slowly be able to trickle that in. The AI technology itself is not going to be able to differentiate itself between, some of the social norms that we are seeing here. But it is going to be a collective responsibility of our citizens, of us to be able to ensure that we have unbiased AI technologies and outcomes in the near future. It's not going to be today, right? As we know, everything is evolving, and we need to make a conscious effort to ensure that those algorithms are going to be trained in that particular model.
But I think to also add to that, large language models today are, we can say, start of it, because we don't need to be expert in coding to train the model. It's just basic question and answers that we want to put together for our use case, and we can basically take the parameters online and we can train them with our natural language. So that's the beauty of LLMs today, and that's, I think, the first step to this.
There will be certain areas where definitely generative AI models will help actually remove that barriers. But for disease conditions and specific diagnosis, we may still need to feed in certain specific data coming from that kind of a population to be able to hone in on the model to make accurate predictions.
What is the business model this technology is adopted to?
Was your question, what is the business model that
Business model this technology is adopted to?
It depends who is actually creating the solution and who is selling it. But again, it all goes back to what is the value that this solution is creating. Can it be sold as software as a service, or is it a product? Is it an application? Where does it reside? And I think that's every specific vendor, healthcare provider, or a payer who is actually taking this will decide how those business models work. There are many ways to define business models, and it all will, at the end of the day, depend on the value and the feasibility with which we can show that this can bring value.
So in the physical science world, I'm up here, a chemist will do some experiments, test a hypothesis, publish data, and people all learn from that. We're gathering all this data that's then anonymized, if that's the right word, so that, okay, I've got this specific type of cancer. Your analysis says that based on where we are now, here's the best treatment method. But where does it track me 2, 5, 10 years out to say that did or didn't work, to then get back to improve the model to say that did or didn't work? I mean, look at what's happened with COVID and how much we've evolved in 3 or 4 years of how we treat people. And I wondered, how does a model learn more, or are we stuck in, all the medical data of 2024 goes into the model and it never grows or never learns anything more?
Being able to train the model with data consent obviously will be important, right? And indeed, when we talk about operational aspects of this model, training the model consistently from time to time to better its output is very important. And even in the healthcare sector, before we release anything to the field, there are multiple trials that we do on specific patient subsets, which sometimes are 5 years, 7 years, 10-year studies. So it is that we follow the protocol, which is much longer, and that's why adoption to technology is also longer in healthcare, right? But that's a small subset. To your point, how do we make it generic so that once it's in the field, it is able to learn consistently? And that is where those data rights and opting in and consent and all of that play in, where we also have algorithms that will anonymize data so that it's not their personal information that is being utilized within the training models, but it's automatically anonymized, fed into the algorithms, trained, and then be able to deliver outputs back to the patient as well as caregiver, to your point. We need to make that more transparent. We need to bring that engagement back into everyone who is as a part of that care journey and a part of the care team for a given patient, so that everyone feels trusted with what is being collected, what information is being shared, and how can they actually use it to improve their own health as well, right? So those are aspects that we need to work on. And why we talked about Gen AI today is we're really just at the surface of it, right? We believe that these models really will help because it's natural language processing in many instances where you can go back as a question and answer kind of a thing, will help in patient engagement, will help in adoption, and will simplify the technical aspects of it to better integrate with their daily lives and, you know, enrich the outcomes in a meaningful manner for them. So that is where we see the value of this technology newly picking up and doing more. So it's not like AI itself is new, but everyday advancements in the AI model spaces is definitely helping us move in that direction a little bit closer.
We have another question coming in from Zoom. This one comes from Michelle. What tools and resources are or will be most helpful for biomedical investigators using AI in their research? For example, tools to rate data quality, missingness, bias, etc., tools to help frame prompts or problems. What's missing that they need to advance the field?
So the first and foremost thing that I would say is having GPUs to train these models, because if it depends on the use case on how massive we want. For a simple classification model, data can be as simple as maybe 100, 200 rows. But for complex tasks like convolutional neural networks or large language models, it's important for us to start with having GPU, I would say, and then we can go ahead, and we do have so many out-of-the-box algorithms that we could implement from scikit-learn library in Python. So I would say they can be the starting steps.
Want to talk about graph models and how they allow you to not have like relational database kind of a schema?
Yeah, so we can, with data, like for example, Twitter, where we can establish relationship between person to person and person commenting on a post or following a post. It's very important to understand relationships between the data, and to reduce redundancy, graph databases also come into picture, which basically will cut short the amount of storage that we would need in terms of the data.
Another piece I would just add there is infrastructure is key, right? Not all this data can be hosted on anybody's specific computer. So you need to have like a data lake where you can bring all this data to a central repository, be able to make those connections across many different multiple data points, and then be able to apply these technological aspects. But then the last part of it is also visualization of it. How do you visualize that data back when you have finished analyzing it in a meaningful manner to be able to quickly identify the outcomes and be able to present it? So those are all aspects of research, as well as, you know, anywhere that somebody's building a tool like this, which would be essential.
Right. I see no more questions in our Zoom screen. I see no more hands up in the audience. Well, we have one more question that we can get in here. I think we can probably safely say this might be the last one for the evening.
I'm going to actually try to answer the question on personalized medicine, and you can tell me if I could be right. I think it's kind of a little bit hyped up and just too early right now to have truly personalized. And the reason is, I think recently Google announced some AI model that could take the sequence of amino acids and predict the protein structure. So let's say you want to have a truly personalized medicine. You'd have to somehow have that patient do a genetic analysis, predict all the proteins, and then say, this is going to interact with these three medicines, and actually this one from manufacturer B is the best, or none of these, we have to formulate something new. I think that's just, you know, 1 or 2 or multiple decades out from our current level.
I mean, I wouldn't think so. Like a lot of actually pharmaceutical companies, and I don't work in pharma, so I don't want to speak as an expert here on anything actually. But pharmaceutical industries are investing heavily in tools that would be able to utilize each of those things while they're actually doing drug discovery. So instead of waiting for 10-year patient trials, they're trying to see how they can leverage data to be able to feed into these multiple simulation models with protein structures, with the genetics of patients, and be able to determine which ones are the best in terms of, personalized medicine. It also is maybe, more applicable to certain complex disease conditions that are not easily treatable, right? That is where maybe some of these applications would work better versus just having it for any and every kind of a disease state, where it may not make much sense or cost effective from that perspective. Would you agree?
Yeah,
Linda?
I,
Is there
that's
anything you would
perfect.
like to add?
No, I think that's perfect. Yeah.
So I would say it's growing rapidly in research, and we may see the outcomes of it in the next few, I don't know, 5 to 10 years maybe. But like we always say, healthcare is a little bit behind in terms of adopting everything, but we need to be careful and the right balance of technological advancements versus, having the right safety protocols, making sure we have thoroughly done our job and validating it to the nth degree is very important in healthcare space. So each of those delays are maybe acceptable.
All right, folks, I think we're going to wrap it up for this evening. I just want to thank Dr. Anandi and Prashanthi for that fascinating presentation. And thank you to our on-site audience, and thank you to our remote audience at home.
Thank you so much. Thank you so much. This is actually a very fascinating topic, and we're just scratching the surface of it. It's also it can get complicated very quickly, and we really appreciate all the questions and the engagement that we had from the audience today. So again, thank you, Carnegie Science Center. Thank you, team, for this awesome opportunity.
Thank you.
We're so glad to have you. And audience, I'll just remind everybody that this program will be available on the Science Center's YouTube channel, usually within the week, if you'd like to share it with anybody. And we really hope that you will join us back here next month on Monday, March 4th, where we are going to have the pleasure of hearing Miss Tracy Baton as next month's speaker. Thank you. Have a great night.
Please don't forget to take your trash with you when you leave. Thank you.